You know, the internet feels like pure magic, right? You click and stuff just appears. But what if I told you it's not magic at all? It's actually a real physical system of wires and routers and rules all working together perfectly. Today, we're going to rip back the curtain and see how the whole thing really works. All right, let's get into it.
I mean, seriously, think about it for a second. You click a link to a website that could be halfway across the planet, and poof, it's on your screen in less time than it takes to blink. What kind of invisible, lightning-fast journey did your request just take? Well, that's exactly what we're going to follow, step by step.
So the second you click, your computer doesn't just send one giant message. No way. Instead, it fires off your request, but it chops it up into thousands of tiny, bite-sized pieces. We call these packets, and each and every one of them is about to head out on its own little adventure.
Now, for any of this to work, computers can't just yell data at each other randomly. That would be chaos. They need a shared language, a kind of digital etiquette. These rules of the road are called protocols, and they make sure every single conversation between devices is orderly and actually makes sense.
Think of it just like this. You wouldn't walk up to a total stranger and just shout, "Time," right? Of course not. You'd say hi. You'd wait for them to say hi back, and then you'd ask your question. Computer protocols do the exact same thing. They do a little digital handshake to open a connection before any of the real data gets sent. It's all about polite, effective communication. Okay, so this is absolutely crucial. Each one of those little packets needs to know where it's going. So it gets a digital address stamped on it, which we call an IP address. This unique string of numbers is basically a postal address for the internet, making sure your request for a funny cat video doesn't end up at your neighbor's online bank account.
Here's a good way to picture it. Your router, that little box in your house, it's like a local traffic cop. It looks at the IP address on every packet leaving your home and points it in the right direction. But the roads themselves, the actual digital highways that data travels on, those are all built and run by your internet service provider, your ISP.
All right, so our packet is packed and ready to go. It zips out of your router and immediately hits the local streets of the internet. This is your access ISP, like Comcast or maybe your university's network. Think of it as the on-ramp to the much, much bigger digital world. From there, our packet gets handed off to a much bigger network, a regional ISP. This is just like moving from a quiet neighborhood street onto a major state highway. This regional network connects thousands of those smaller local networks together, and it's designed to handle a whole lot more traffic.
And now, our packet merges onto the internet's superhighway, the global backbone. This is the big time. We're talking about a handful of massive Tier 1 ISPs whose enormous fiber optic networks literally crisscross continents and dive under oceans. This is what carries the vast majority of the world's internet traffic. And this brings us to maybe the single most important idea to get your head around. The internet isn't one thing. It's not a single entity. It's a massive, sprawling, decentralized collection of tens of thousands of individual networks all agreeing to talk to each other. It really is a network of networks. So how do all these different, often competing networks actually link up? Well, sometimes two huge ISPs will just agree to connect their networks directly, for free. That's called peering. But way more often, they all meet up in a neutral spot called an Internet Exchange Point, or an IXP. Seriously, just picture a massive airport where hundreds of different airlines all have gates so that passengers, or in our case, data packets, can easily switch from one to another to get where they need to go. So, after hopping across all these different networks, from local to regional to the massive global backbone, and then all the way back down again, our little packet and all of its siblings finally arrive at their destination, the server that's hosting the website you wanted to see. But wait, we're only halfway there. Now the server does the exact same thing in reverse. It grabs the web page you asked for, chops it up into a whole new set of packets, stamps your IP address on each one, and sends them all flying back across that huge network of networks. And, get this, they often take a totally different path to get back to you.
Finally, back at home, your computer starts catching all these incoming packets. And here's the really cool part. They almost never arrive in the right order. But another protocol, basically a little digital foreman, is there waiting. It checks to make sure every single packet made it home safely, and then it reassembles them in the perfect sequence, and boom, the web page loads on your screen.
And that whole thing, that incredible trip from your click, across the world, through dozens of different networks, and all the way back, happens billions of times every single second. It is an absolutely mind-boggling system, which really makes you wonder as we start connecting the next billion devices, our cars, our fridges, everything. How is this incredible network of networks going to evolve to handle it all?